So we need to obtain the value of the vector valued function r, and it has to satisfy the differential equation second derivative of r with respect to t equals to a constant vector e. Also, here are some conditions that are provided that when t equals to 0, so t is just a parameter, then the r vector is going to be 0, and the first derivative of r with respect to parameter t, that's equals to vector u. Let us begin. So we will consider the given equation. So here we have second derivative of vector r with respect to t, that's equals to the constant vector a. What we'll do, we'll take the integral on both sides. We'll take the integration of d squared r over dt squared with respect to t. That means we'll multiply it to dt. So this will be equals to integration of vector a dt. Fine. Now integration of the second derivative of r with respect to t. So that's going to give us the first derivative of r with respect to t. And this will be equals to, we have a vector. So a vector a is a constant, as already mentioned here. This will be multiplied to integration of dt. So that's t plus some constant of integration c1. Now here c1 must be a vector. The reason behind this, on the left hand side we have a vector, and on the right hand side we already have a vector, which is a vector times t. But in order for this particular equation to hold, c1 must also be a vector. Then only this entire terms, the two terms on the right hand side, gives us a vector quantity. Right. Now what we will do, we'll again take the integration on both sides with respect to t. So that means we have dr vector over dt multiplied to dt. This will be equals to a vector times integration of t dt. So a vector is a constant. We have taken it out of the integral, dt plus c1 vector times integration dt. c1 vector is also a vector constant. Now we have pulled it out of the integral. Now integration of dr over dt, so that's simply going to be vector r, and that will be equals to vector a multiplied to integration of t, so that's half t squared, plus c1 vector times integration of dt will be t, and we will have another constant of integration whose value is c2. So let's call it c2 vector. Now here we have obtained the vector valued function r, which is a function of the parameter t, but we have two constants, c1 vector and c2 vector, whose value we need to obtain by using this given condition. So let's start. So when t is equals to 0, so let's call it equation number 1. When t is equals to 0, then equation 1 will become, so we have r of 0, so that's equals to vector a over 2 times 0 squared plus c1 vector times 0 plus c2 vector. And here it's given that when t equals to 0, our vector r is also 0. So that means this entire vector valued function becomes equals to 0, and this will be equals to c2 vector. So this implies that our constant of integration c2 is 0. Now what we'll do, in order to obtain c1, what we'll do, we'll take the derivative of equation number 1 with respect to t. We don't have to do it. We already have dr over dt. So let's call it equation number 2. So here equation number 2, we will compute the value of this particular derivative at t equals to 0. So that gives us a vector times 0 plus c1 vector. Now in our question, we are already provided with dr over dt, so that's equals to vector u. So that means at t equals to 0, so this will be u vector equals to c1 vector. So we have obtained the value of c1 vector. So that means our value of the vector valued function r vector, which is a function of the parameter t, so that will be half multiplied to a vector times t squared plus c1 vector. So c1 vector is simply vector u, so we have u vector times t plus c2, and c2 vector we have obtained it to be equals to 0. So this is going to be the value of our vector valued function r.